Hello and welcome back to our course about summary statistics. So why are summary statistics useful? Let's assume you have an array with 1000 or 10,000 elements and you want to summarize these elements in one or two numbers. And for this task, NumPy provides us with many options how to summarize large numerical arrays. So first of all, let's import NumPy. Then we create 11 random integers in the range 1 till 100. And assign the variable a. Then we sort a. There we can see, so now we have the lowest number is 18, 48, and the highest integer is 99. And then we can calculate the maximum of our array, so the highest element with the method .max. It's 99 here. And we can also do this job here by applying the function np.max. So this gives us the same result. And earlier we learned about the function max, so we can also apply the function max. So you can see there are actually three alternatives to calculate the maximum, and also with the minimum. There are the same three alternatives, and I only show here the numpy method.min. So I would expect 18. And we can also calculate the mean of all elements with np.mean. So it's 74, or we use the method.mean. It should be the same. And we can also calculate the median. So let's run. It's 84. So what is the median? So the median gives us actually the point where 50% of all other points are lower than, and 50% of all elements are higher than the median. So we have here 11 elements. The median is the sixth element, so we have 5 elements which are lower than the median and 5 elements which are higher than the median. So this is, in very simple words, in this simple example here, the median. And we can also calculate the standard deviation of our elements. So it gives us 24. So the standard deviation is a measure of the variability of our elements. So if all elements would be, let's say, 50, our standard deviation would be 0. If the variability is quite high, so then also the standard deviation is high. But I don't want to go into statistical details here. And variance is also a measure of the variability. And actually standard deviation is the square root of variance. But this is not a course about statistics actually. And we can also calculate the percentile of our array. So let's say we use here the function np.percentile. We have our array A, and then we say we want to determine our 10th percentile. And that's 48. So what does it mean exactly? So the 10th percentile means that this is the point actually where 10% of all the other elements are lower than this point, and 90% are higher. So you can see here we have the 10th percentile 48. And one element is lower and the other 9 elements are higher. So this is in easy words the percentile. And also we can calculate the 90th percentile. So it's 98. And you can see here 90% of our elements are lower than the 90th percentile. So we have here 9 elements. And only 10%, or in this case here 1 element, is higher than the 90th percentile. Alright, so let's again create an array with 11 random integers in the range between 1 and 100, and let's call it A. And we create another array with 11 random integers in the range 1 and 101, but you can see here, so we have a different random seed, and I would expect now that we get different random numbers here for our array B. There you can see here, so the arrays are different. Now we can calculate the covariance of A and B with the function np.cov. And the covariance is actually a measure how two arrays or two sequences of numbers move together. So here it gives us a matrix. Here the first element is actually the variance of element on NumPy array A. Then here we have the variance of our array B. And here we have 2 times the covariance of A and B. So as you can see here with the minus sign, both sequences should be kind of negatively correlated. And we can better see this by calculating the correlation coefficient by using the function np.corrcoef. So also here we get this is the correlation of array A with itself. It's 1, So it's no surprise that A is perfectly correlated with A. Here you get the correlation of our array B with itself. And here we have 2 times the correlation of A and B. And it's negative. So whenever A increases, B should have a tendency to decrease. And the correlation coefficient is between -1 and 1. And -1 means a perfect negative correlation. And 1 means a perfect positive correlation. And the correlation of 0 means actually no correlation. So here you can see, we have a light negative correlation between NumPy array A and B. And actually, because we created both arrays independently and randomly, we would expect actually to have a 0 correlation between those two. And if you would increase the amount of elements in each array, so let's say instead of having 1,000 elements, I would assume that we get a correlation which is very close to 0. Alright, so this is it. This was a quick overview over summary statistics. So there are a lot of options here in NumPy, and in the next session we see us again with visualization and regression with NumPy. See you there.